So let's get one question out of the way. Does the world really need another programming language? Probably not. No. You're listening to Marianne Writes a Programming Language. And I'm Marianne. I have always wanted to write a programming language. I figured I would learn so much from the challenge. Even 15 years into my career in technology, I still feel like there are all these weird holes in my knowledge. I know a bit about abstract syntax trees, a bit about tokens, a bit about compilers and bytecode, even a bit about logic gates, but I don't have a clear sense of how all those things work together. One thing my career so far has convinced me of is that no knowledge is useless. Things I learned in the past become valuable in the most unexpected ways. The other reason why I want to write a programming language is because I can't find a language that does exactly what I want to do. If you're familiar with my work, you probably already know that I'm very interested in complex systems and models. I spent a year or two exploring formal specification, a set of tools that I still use, to be honest, before I realized that languages like TLA Plus and Alloy are looking for mathematical correctness, and that wasn't what I wanted, what I was interested in. I didn't want to know if certain problems are impossible. I wanted to know how likely certain types of problems are in a given system. I wanted to model resilience. But one thing at a time. We'll get to all of that in more detail later. So, how exactly does one write a programming language? When I started this project, I thought finding a jumping off point would be easy. I typed, "How do you design a programming language?" into Google and expected to get back at least a few Medium posts laying out the basic decisions. Even knowing very little up front, I had a sense that in order for a programming language to work, there had to be some sense of cohesion in its design. You couldn't just pick and choose things you liked in other languages and just think it would be okay. Some things would not work with other things. But what were those critical choices? I was surprised to find not much information. I expected someone to have developed a menu of some kind, even a primitive one to serve as training wheels for beginners, even a complete bullshit one drafted to start fights on Hacker News. I expected to be able to skim a few opinions and have a good idea of where I wanted to start researching. Except I couldn't find anything like that. A theme that's going to come up a lot in this series is the incredible divide that exists between the academic world of programming and the commercial world of programming. As we go down this rabbit hole together, we'll talk about completely different styles of programming, strange data types. Jesus, there's a whole world of obscure experimental languages that appear in research papers, rack up a host of citations, and never touch an actual computer other than their inventors. At one point, I asked a researcher I interviewed for the series, why do CS professors keep publishing descriptions of implementations without actual code? Why do I see demos of things, but no source code repositories? And he told me, because they're ashamed. If they share their code, other people will find all their programming mistakes. And to me, this is a really fascinating problem. One side of this divide is developing really interesting stuff, but doesn't know how to produce mature, production-ready code. The other side has those skills, but finds the language of academia to be inaccessible and difficult to parse. In my search for an overview of the theory behind designing programming languages, I kept getting referred back to these thick computer science textbooks. The Wizard book, the Dragon book, you've seen them referenced as well, I'm sure. I felt like this was probably a bad place to start. Perhaps I'm reckless or just intellectually lazy, but adding a few 100-page college textbooks to the top of my reading list seemed like a good way to destroy my momentum really fast. Even though without question, that was the proper way to learn. It would do me no good at all if it killed my interest. I can't remember how I found writing an interpreter in Go, and just one of those things, I guess. But once I found it, I knew immediately this is how I wanted to start. I recently had started learning Go for work, and I can't tell you what a relief it is to have books about general programming concepts not written in Java. Thank God. Even better, writing an interpreter in Go implements a programming language called Monkey, which was developed specifically for the book, which meant the author was someone who had actually gone through the process of designing a full programming language.
I think you're overestimating how novel Monkey is.
And that is Thorsten Ball, a creator of Monkey, author of Writing an Interpreter in Go, and also its follow-up, Writing a Compiler in Go.
So I didn't set out, to create a completely new program language. I couldn't, no. I don't know. I wouldn't even know what it should do. But what I realized, and I'm sure you've seen this too, now that you dug into this, there's a ton of material on how to create program languages. And in my experience, it falls into two categories. The one category is this overly academic, textbook kind of stuff where it says it doesn't even show you what the program language looks like. It shows you only snippets or it glosses over the syntax and says we don't have to worry about syntax. Let's just use this Lisp as a stand-in, whatever. And then on the other hand, you have these, tutorials, blog posts that show how to build a program language, and they mostly show really small toy examples. And they strip it down so much that it's often just a calculator, like a REPL where you can type in 1 + 2 and you get out 3. And what I wanted was something in the middle, fully documented, including tests with the real syntax, like no parentheses, Lisp stuff, which I love. Like, for the record, I'm a Lisp fan, but what I wanted was the real thing. Like, all of the program languages, the real ones, they have curly braces and they have keywords and whatever. And I wanted that. Like, how does that work? So what I basically ended up doing is writing a Lisp and then putting the Monkey, outfit on top with the curly braces and the FN keyword and let and whatever. But it's really similar to JavaScript in a way. Mm-hmm. In the best possible way, I guess. And JavaScript famously is also, it started as a scheme implementation, like a really small scheme implementation. You have, it's immutable by default. You have first-class functions. That means you can pass the lambdas around. You have higher-level functions. You can return functions from other functions. Not a lot of crazy data types. No static type system. So I just, took a minimal scheme, added the curly braces, and arrays and hashes and the syntax for literal. So you can literal type. So you can type a array literal or like a hash map or whatever, and that's basically it.
So, what were the kind of design choices that you made when you were thinking about what Monkey should look like? I mean, not in terms of curly braces or no curly braces, but in terms of should it be strict typing or dynamic typing, or should it be this or should it be that? How did you think about? Was it you had a design phase with Monkey, or was it just I'm just going to build things and we'll see where we end up, right?
The second one, yeah, definitely. And honestly, I feel like my brain is not built for the first type of that. It's, if you start out and want to design a program language from the ground up without, building it, at least in a prototypey way, I cannot think that far ahead. It's that the layer we're talking about here, the programming language itself and the built-in functions and the keywords and how they work together, they are so deep down that every little change you make has a lot of ramifications further up.
Yeah.
And that is the most impressive thing about programming language design. If you for example, look at the Go program language. They, there's this whole debate about should Go have generics or not, and the Go authors famously, pushed that decision like in front of them and didn't want to make a decision for years, or said no, Go doesn't need them, and there's too many, ramifications and effects that would have, and people would just say, oh, can you just add this and can you just add that? And they experimented around and had these prototypes and design concepts, and I was so impressed by whenever they presented, like, oh, we made this attempt and turns out that this would result in code that looks like this, or we made this and that would change Go code to be written like that. I was so impressed by their understanding of basically the power they wield in a way. Yeah. Because look at Go or any other language, the idioms you have in the language, they just come from all of the pieces lying around, basically. Like people go, Go's error handling works like this, so we're going to use it like that. This is what an error looks like, this is how we're going to use it, blah, 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 blah. And if you add more pieces into that mix, suddenly the whole game changes. And suddenly, if you add the wrong piece, you can change how code is written in that language completely, Yeah. I guess Java is famous. Like, if you look at Java in the pre-generic days, when they didn't have generics, looks completely different than modern Java. Yeah. And the same goes for C++, right? They added a lot of stuff, and people say, C++ 11 is not the same as the one from the 90s or the early 2000s, whatever. Like, all of this has ramifications.
That's the thing that I think I find the most intimidating about, like, even undertaking this, is understanding that tiny little design decisions I don't even realize I'm making could have dramatic impacts. Like, I think that Java 6, that is like the point where they changed something fundamental in how things works, and like everybody's struggling to migrate off of, like the Python 2 to Python 3 story of like, oh, we did this wrong, we're going to do it differently so that we can grow and continue to thrive as a language. But it's going to be really, really hard to make the transition. Like, I worry, probably unnecessarily, because to reach that point of success is, like, in and of itself unlikely, right? But still, it's like, as like, a creative undertaking, you always want your work to represent the best that you can do, and you never want to, like, look back on it and go, if I had only thought a little bit harder about it, I could have seen that problem coming. Yeah. Is there anything in Monkey that, like, in retrospect, if you were to go back, you would think, I would have done that differently in the way it's designed?
Yeah. I added return statements to Monkey. And there's two ways to return a value from a function in Monkey. Either you add a return statement and that returns the value, or you simply it uses the value of the last expression.
Right.
So if you have a small function and it doesn't take parameters, but you just put in 1 + 2, then it returns 3, this function. Or you can add, an early exit and say, if a greater than 3, return, 5, closing brace, and then 6 or whatever. So you have an early exit. And those return statements, I added these on a whim. I was like, I like the implicit return, because I was used to it from Ruby. I really like it because it allows you to write these really dense small functions and pass them around. Scheme again,
Yeah.
Return statements are not scheme, you know. So suddenly, once you add return statements, you kind of jump into this whole paradigm and go like, here I am, like, here return statements, and we're just going to exit from this function only. But it doesn't really fit a lot of the other stuff, and it breaks kind of control flow. For example, if conditionals are also expressions. So if you say if one, if true, then 1, else 5. That whole thing evaluates to 1, right? But you can now add a return statement in the consequence or the alternative arm of the if conditional. And that suddenly changes the control flow, because now this is not an expression anymore, but it's an expression with like a hidden control flow statement in it. And that needs to go up, right? And then, as I said, like I have first class functions, I have higher level functions. That means you can return functions from other functions. That means you can have 2 functions in another function and return from those 2 functions, right? And this is, I had a few bugs in there, and it's just like, it's horrible. Like you can make it work, and it's working now. I guess there's still some bugs in there that nobody has found it, but it's that was one thing where I was short-sighted and was like, okay, I'm kind of trying to shoehorn something into this, but I don't know what I'm doing, and now it's really hard to implement.
I'm seeing more and more parallels between the task of writing a programming language and working with complex systems. I can't figure out if that's because I focus on complex systems and therefore am predisposed to see them everywhere, the same way a cardiologist will think of problems with your heart and a neurologist will think of problems with your brain. But it does seem to be the case that programmers create languages without being able to fully anticipate exactly how they will be used or how technology will change around them. Is the solution to this dilemma the foresight earned through experience? Should a student's first programming language be treated like the first pancake off the griddle and just thrown away? I think about the stories I heard about the programming language C and its development. Like the conventional origin story about C is that Dennis Ritchie just walked into work one day and decided to create it. In reality, the development of C started with the development of BCPL and B. Computer scientists involved in those languages would build things, then change the implementation of those languages to clear blockers they had discovered, and in fact could only have discovered through using the language. C then started from all of those lessons learned, and then itself had many different conflicting and undocumented implementations before it was standardized in 1982, 13 years after its development had started. I guess, from the perspective of somebody who has now done this for what sounds like 2-3 years, right? Like the first book took a year, the second book took a year.
Yeah, first book was released in 2016, and I started
way more than that then.
digging it in 15, I guess. Yeah.
Yeah. So the 5-year journey, if you could highlight almost like the decision tree, if I can call it that. I think there is a certain baseline level of decisions that once you have gone that direction, other things are taken off the table. Like what you were saying with return statements. Once you decided that you wanted it to be kind of a list scheme flavored language, return statements just kind of didn't fit and didn't kind of work. How would you think about that in retrospect? Were there core decisions that stand out in your mind as I went down this road and that took all of these things off the table, logically?
I don't think I can name all of them, but a few stand out, and it won't be in chronological order.
It's all right. That's
but
fine.
So as I said, the big one was Monkey is a scheme in disguise, right? It is a pretty simple language. It has only a few data types, first class functions, and I added the syntax on top of it with the braces and the short keywords and let statements and stuff like that. So this set the basics, and then I realized once I implemented that and actually wrote it down, I realized that's not really useful, So I added more data types like hashes and arrays.
Mm-hmm.
So to make it more practical and make it more relatable or interesting, I guess, because this was always missing. And once you implement an interpreter that can do, binary expressions with numbers and booleans, it's cool, yes, but it's not 5 hours of fun, So I added these, and then somewhere around that time, I guess, I also made a decision to not add assignments or mutability to the language. So everything is basically immutable. You cannot say let A equals 8 and then A equals 5 or whatever. That is right now undefined behavior. Like, it's not implemented. And the reason why I did it was because that A equals 8 or 5 is simple, sounds simple, right? But once you add mutability and you can reassign stuff or assign stuff, you also need to incorporate that in your closures, which captures state, right? Like you have a closure is a function that wraps or closes around state. So what if it closes around state, like a binding of a name, like A equals 5, right? When the closure is created, A equals 5. And after the closure is created, you say A equals 8 now. What does the closure return?
Right.
That is a decision you have to make. And different languages have different answers to this, right?
Right.
That has effects. Like, your decision there it's a simple decision to make, but it has a lot of consequences. Right. And I kind of avoided that decision or said it's immutable. But it also means it's not easy to implement loops, right?
Yeah.
Because a loop is based on a condition that changes, I guess.
Right. Got to increment the I, right?
Exactly. Yeah. And if you don't have a way to change something, that's not straightforward to implement, right? Like a for loop, like I equals 0, I less than 10, I plus plus, that includes assignment, that includes mutability.
Right.
So if you don't have assignment, that's off the table.
That's interesting, because I would not have made that connection until you pointed it out. And I'm like, oh yeah, you really can't, can you?
Yeah. So I made a live stream in winter last year where I, let's try out this live streaming thing, and I said, like, let's add loops to Monkey. And I'm not sure whether you can see it in the stream, but towards the end of the stream, I was like, damn it, I need assignment for this. Like, the problem is you can of course you can write like while true and then have it execute for all of eternity, right? Or you can say while my blah 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 function, and where blah 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 function is a built-in function that returns whatever. But as you know, in the books, everything is test driven, so we write test first, and you want to make sure that it works. And there's no good way to write a test for loops without basically do like a dependency injection or mocking of the whole system, which breaks this whole idea of really short and easy to read tests. And
right.
So yeah, and then so there was assignments and mutability, and I didn't want to add classes. Just aesthetic reasons, I guess. Like the scheme / list pie horse, where like, objects are just a poor man's closure, and closures are poor man's object. So if we have closures, we don't need objects. Of course, readers are interested in like, how would you implement classes? But that again is such a seemingly small decision that has incredibly huge consequences. Like look at JavaScript. Like a couple years ago, they added classes, and people did classes in air quotes, by returning objects with methods from other functions. But now that you have the class keyword and like this whole syntactic structure for them, it changed how people write code. So it's again, like huge consequences. And I didn't want to have classes. I don't think I'm a huge OOP fan anymore, but I just didn't want to have them. And also, everything that I just said, I had to fit in a reasonable amount of pages in a book.
It's not a 5-part series then.
Yeah, and as you know, like everything is test driven, so it's not just the implementation, but it's also the test for the implementation that you need to show in the book. And every bit of code, I think only 2 helper functions are not shown.
This is the place where something clicked for me. Immutable data, classes, loops, implicit returns. What we're discussing are the conflicts that arise when mixing functional programming styles with procedural programming styles. So maybe a key part of that menu I've been looking for is about the assumptions that ground those styles. How do we want to handle state? Are functions first class? Is inheritance important? I think I need to get a few more books. You've been listening to Marianne Writes a Programming Language. Now, unlike my blog, producing a podcast is not exactly free. So if you'd like to support this project, please consider becoming a patron. Patrons get access to lots of great extra content, including the full recordings of all the interviews I'm doing, and a chance to play with the language I'm developing and provide feedback before anyone else. Here's a sample of what's available this week for patrons. I have not yet finished the second book, so this is a spoiler. I guess.
Monkey lives.